let's do a weird experiment. So I was thinking about fines migrating or not migrating much, and I thought, why not do something really crazy? So I wanted to use really large particles. So I decided to use whole beans, and I stacked them in a compresso, and then put spent coffee grounds on the bottom and spent coffee grounds on top. So the spent coffee grounds on bottom will help slow down water, and on top they should simulate if there's any motion in the particles with respect to the larger particles like the coffee beans. So the distribution here is very bimodal because you have these really fine particles and really large particles. But this is also not representative of coffee grounds because coffee grounds are usually a continuous distribution. So in this first test, I just pushed water through, and the water went through a bit slowly. So I took some time and just let the water pour. I had too much grounds on top, and so it was hard to pour water in and also push. And eventually the water finds some channels and starts running fast through the larger particles. So in this test, I didn't notice a lot of particle motion, because you'd assume some particles at the boundary between the spent grounds on top and these coffee beans would start to fill in the cracks or be pushed along with the flow. And some of them do, like in this video, you can see some particles floating around and moving around. But it's not quite clear, and again, I wasn't able to push as much pressure through. So there's definitely some particles flowing, there's some channeling occurring. It's just a question of how much is occurring. And as I pushed more water through, the chamber didn't really fill up with water. So it doesn't really show what the inside of a coffee puck is like, because usually the inside of a coffee puck has water filled throughout. So that causes a different dynamic in terms of how water flows and how where pressure is applied. Because in a pressurized system, the pressure is the same throughout all of it. So some water spilled out of the top as I started to apply more pressure, and you can see more particle motion in the middle. But again, it's hard to see how much, or it's difficult to say like how much water you had to push through to get some particle motion. So I eventually stopped this, and I just pull it out to take a look at the result. And so we had some grounds in the coffee beans, and you had a pretty thick puck. And again, there's a little bit of grounds, but not a great deal. And so I decided to try again. But this time I used wet coffee. So I had the coffee in the bottom that was wet. I rinsed the coffee beans off. I put them back in. I took the top part and I cut it a little bit, and I put this back on top. And now I push them against the coffee grounds. So this way I don't have to worry about this pre-wetting that goes on in the beginning of the other video. The trouble here is that it was kind of hard to see. But also I have here both the starting point and the progression, so you can kind of see what happens here. So in this video, I put water through and pressed it a few times, and then when I would push all the water through, I would take out the plunger, which would move up the entire puck stack, and then I'd slowly tap the whole compresso against the table to get that stack of coffee and beans to go back down. So this is like the first press. So what's interesting here is the water goes in and goes down to just the boundary with the coffee beans, and it doesn't go further on its own until I actually press water through it. And then you start to see a huge amount of motion in terms of sediment flowing through. Much different than before. So now I take it out. I just cut the video to the next part. And so I push this all down again. And again, you can see a lot of sediment moving, but then the sediment starts to clog up at the bottom. And so the sediment stops moving. And this particularly comes out in this next section here. There's still some spaces right in the middle, and as more water is pushed through, more particles come in there and they fill up, and then you stop seeing water movement through the center of the puck. Or you see water movement, but you don't see particle movement, which is important. So what this experiment is telling me is that if you have these big, large gaps, you could have particles move through them and fill them, which is essentially what Fine's migration is saying. But the theory of Fine's migration is that these particles would continue going through all the way to the bottom where they accumulate. Where in this case, most of these particles are just filling up the gaps and then they're not moving anymore. So the migration only occurs until the any free spaces due to the particle size fill up. And again, this situation is the coffee grounds were very bimodal. So usually you have a variety of coffee sizes, and you wouldn't have a situation where you have these really large chunks and really small chunks and nothing in the middle. And so this is the output. So the coffee grounds are filled in all the spaces with the larger